Assalamualaikum to Prof. Dr. Azhar. We are presenting artificial intelligence projects for the Smart Cable Identifier. So before that, we are going to introduce ourselves. My name is Nurul Atira binti Ismail.
My name is Sarah Adrianamu.
My name is Nur Afika binti Muhammad Zaman.
Okay, next slide. We have table of contents. So in this presentation consists of project background, problem statement, objective, scope, demonstration, future improvements, and conclusion. Next slide. We have project background. So project background is the why for our project. So the first one, we have the digital dilemma, which is modern life requires multiple cables such as USB-C, micro USB, and Lightning. These three cables, which is frequent cables for users these days, that look nearly identical. So for modern life nowadays, we have a lot of devices that need constant charging. So usually these three cables involved, which look nearly identical. So the next one is the struggle. Users often face confusion, especially the elderly and those with visual impairments. So the struggle which you have three similar or identical looking cables, and you sometimes face confusion, especially for the elderly, that when you look at the cable, you cannot identify it, which is which. So even with the visual impaired user that look at the cable and could identify which is which as well. So the next one is the risk. If forcing the wrong cable can damage expensive device ports and cause user frustration. So if someone were to pick up a wrong cable and force it into the device port, it could easily damage the expensive device that you have. So the solution that we have of why behind our project is the Smart Cable Identifier, and the short form for it is SCI, which is a simple computer vision tool to bridge the gap between technical complexity and daily conveniences. The next one, we have problem statement. So the problem statement is we would identify the core issues with visual similarity, which these three cables have really small connectors that look nearly identical, causing frequent confusion for users. Just as what I explained earlier, having these three cables that look the same usually could cause confusion with the elderly or the visual impaired users. So next we have accessibility barriers. Lack of simple tool to help elderly and visual impaired users identifying cable. So that's why we are introducing the Smart Cable Identifier to solve this issue easily. Next one, we have risks of damage. Forcing the wrong connectors into a port can lead to costly hardware repairs. So just as what I said earlier, if you were to grab a wrong cable and then you force it into your device ports, could easily cause your device to be damaged. So for that reason, we are introducing the Smart Cable Identifiers. For the objective, I'm going to pass it on to my friend Sarah to present it.
So the objectives of this project, what we aim to achieve. Number one is to have accurate recognition, which the system should be able to classify USB-C, micro USB, and Lightning cables using a trained AI model. So the system should be able to differentiate this type of connectors accurately. And next is simple assistance, where we can demonstrate how low-cost computer vision solves everyday accessibility problems. So as we know, Google Teachable Machine is a free tool where people with little to no coding knowledge or experience can easily use. So by developing this project, we can show that tools like Teachable Machine are easily accessible to everyone, and we can create a project that we can use to solve everyday problems like this one. And next is to have live identification, where the system should be able to provide instant on-screen text identification as soon as the cable is detected by the camera. Next is the project scope. The first one is target connectors, where the system focuses exclusively on USB-C, micro USB, and Lightning. Technology stack. This system are built using Google Teachable Machine, the image project part of the Teachable Machine. Input, output. So the input is real-time webcam/phone camera feed, and the output is an instant on-screen text labels for identified cable types. The limitations. So unfortunately, this system does not test cable quality or speed, and the performance is dependent on room lighting and camera clarity. Now let's move on to the demonstrations of the system. I will pass this to my friend Nurul Afika.
Okay, for the demonstrate, I will demonstrate our project where AI or teachable machine is finding the right cable between type Lightning, type C, and the micro. From this table, we will see that from the image, it can significant shape from this type cable and show the algorithm and it can read it correctly. So let's go. We'll turn off the camera. And then, okay. So I will click the train model and we train. From this teachable machine, you can see that we are trained micro USB, we are trained type Lightning, we are trained type C. We give a 10 image sample for each cable type to identification and the shape. So we will try the micro one. So this is the type micro. It can read to 18 to 90% of this type micro USB. So this is a type C. It can read between 16 to 18% to read a type C identification of shape. For the Lightning, it can read it between 18 to 90% for Lightning. So that's all from our demonstrate. So I will tell you about future improvement. To expanding system capabilities, we will product a database, include more cable types like HDMI, DisplayPort, or proprietary laptop charger. It's also suitable for students or users who want to learn the difference between this cable for network field. Okay, a beginner can also learn each type for easy identification by this SCI. Okay, for the next is the mobile integration. It's developed a dedicated smartphone app for on-the-go identification using the mobile camera. Instead, use the web every day, every time. So we will change it to an app for the convenient and a friendly user. For the next one, in-charge detection. It improves accuracy in low light environment and identify damage of frayed cables. It can see which cable is useful or damaged. A good one will be used for daily life, while the damaged one will be notified and be repaired or replaced to a new one for safety purpose. Next one, I will give it to Atira for the conclusion.
So for the conclusion, we are trying to bridging tech and accessibility to everyone. So the first one is by simplicity. We want to prove that AI does not need to be complex to solve meaningful everyday problems. So typically these smart cable identifiers, we really focus on small problems that could easily improve people's life, which if you were to easily identify these cables, you wouldn't, spend a lot of money on your damaged ports. So for the next one, we have accessibility. We would like to empower users to manage their digital devices independently. So for the elderly could also move with the technology as well by using a smart cable identifier. And the last one is impact. For just using a small low-cost computer vision tool can significantly reduce user frustration and prevent hardware damage. So moving forward, we would like to improve in certain things, upgrade our project to significantly reduce users' frustration and prevent any damage going forward. So that is all for our presentation for today. Thank you for listening.